So let's take a look at the proof on page 7. Just because it's in a circle doesn't mean it's got to be difficult. If we're trying to prove these two arcs here were the same, really all we need to do is prove that these angles in the middle are the same. And we're positive that those ones in the middle, we don't even need anything. The reason why it says diameter is to show you that these are straight lines that are crossing. But when lines cross, what type of angles are made? Those two are vertical angles. And we can't call them O. We've talked about this before. Either put numbers in them or call one like AOC and call the other one DOB. And if you know that those angles are the same, then we know these arcs are the same. You can put it however you want. I believe that we spoke about it earlier and said in a circle, or congruent circles, but in a circle, congruent central angles have congruent arcs. So we could just use those same wordings. In a circle, congruent central angles make congruent arcs. Doesn't always have to lead into triangles being congruent or similar or anything like that. Also flip over to page 10. Let's take a peek at this proof. Just because there's a lot of space doesn't mean it's going to be crazy. So let's just put some of this given information in. Circle O with diameter AB. AB is parallel to CD. And we can talk about those chords and put those in too if we wanted to, but that's not really giving us anything. So when we talked about parallel lines, the way they enter is the way they leave. So this arc AD should be congruent to this arc at CB. And if we go back to where we wrote this, I believe it was at the bottom of page 9. In a circle, parallel chords intercept congruent arcs. So if we've got these two arcs the same, then what could we say about segment AD and segment CB? And I believe that we talked about it before as well. In a circle, similar to the previous proof that we did, congruent arcs make congruent chords. And voila, we've got a side. If you also look, angle A and angle B are both pointing to the same arc. So they're both inscribed in the same arc. So we can say that angle, and I wouldn't call it angle A, I would call it like DAE. And the other angle, I would say would be like CBE, are congruent. And we can say in a circle, I believe this was in yesterday's proof, inscribed angles intercepting the same arc are congruent. And that gives us an angle. And maybe when we were looking at this proof statement, AED, it's this triangle right here. And the easiest one are these angles around E. Can't call them E because there's 4 angles at E. You want to make sure that we're talking about that left one, DEA, and that right one, CEB. A few people are putting vertical angles / reflexive property. Those are only vertical angles. And I think we have enough. If we look around this triangle, we've got 2 angles and a side. And we've got the 2 triangles, AED and BEC, congruent.